So let's talk more about enantiomers. We've already said that enantiomers are two molecules that are mirror images but are not superimposable. Now that happens quite a few different circumstances, but the one that we're really focusing on now is the most prevalent, and that's where you have a carbon that has four different groups attached to it. Such a carbon is called a chiral carbon, sometimes called a chiral center. Sometimes you say the whole molecule is chiral. Now you should be able to recognize chiral centers. My figures are rather straightforward, and in the worksheet there'll be some more interesting examples. But anyway, you can see that here is carbon, which I have starred, always star your chiral center. It's attached to four different groups: the hydrogen, the methyl, the chlorine, and the bromine. If I draw out the possibilities, so what I've done here is drawn it out one particular direction, just said that the methyl and the H are coming out at you, the bromine and the chlorine going away from you. Little mirror plane, there's the mirror image, and I've drawn out these molecules for you. So the top one here is just this one, resting a little bit, but you can see bromine and the chlorine on the back, left and right. Look down this way, the hydrogen is going to be on the bottom, the methyl group is going to be at the top. So that's this molecule here, and then this one here. You can see a little bit of a different variation, because what I've done is tried to match this second molecule onto this one, and you can see it doesn't work. I've got it aligned so that the yellows and the greens line up, but then the silver hydrogen would be where the purple methyl is, and vice versa. Hopefully that made sense. It made sense to me in my head as I was saying it. But anyway, here are the mirror images. Here are the two molecules associated with that. This is that one. The bottom one is the one on the right. And what I'm trying to show in this picture is you cannot superimpose them. You cannot match them up. If you match up the yellow and the green, the grey and the purple don't match. Next little molecule to show you here, this is a carbon that's bonded to a hydrogen, a methyl, an ethyl, and an OH. Let's colour code it a little bit. So the OH is red, the methyl purple, the ethyl yellow, and then the hydrogen will just leave us a sort of grey or black in this case. Mirror plane, there's the mirror image. Here are two models I made of it. This is the top one here. This is actually the bottom one, but orientated so that I'm trying to superimpose them. So again, I'm trying to match up. There's the purple matched up, there's the hydrogen matched up, but you can see when I match those up, then the yellow and the red don't match. The yellow is where this red was, this yellow and this red are matching up. So cannot superimpose these molecules either. Couple of other examples. This is an amino acid, alanine. It's got its two mirror images. And then finally, this funky old one here, where you've got an ethyl, a hydroxide, a methyl, and a CH2H. And there again are its two enantiomers associated with that structure, with that chiral molecule.